Welcome back, ladies and gentlemen. In this video, we're going to take a look at how to utilize the Incenter in some actual real-world application. And so, in the process of this, all right, we're going to be thinking about what makes most sense, all right, utilizing the Circumcenter or utilizing the Incenter in application. Okay, so which one makes the best sense based on the scenario? And so it says a city wants to place a lamppost on the boulevard shown so that the lamppost is the same distance from all three of these streets. All right, so we want to know that the lamppost, wherever it is, somewhere, is the same distance from each three of the streets. Should the location be at the circumcenter or should it be at the incenter of the triangle? Well, in order to answer this question is that you have to know what the characteristics of the circumcenter and the incenter are. So let's think about this. The circumcenter was created by the perpendicular bisectors. Circumcenter created by perpendicular bisectors, and our incenter by angle bisectors. Okay? And then we had characteristics of each of these. Well, the circumcenter, if I remember correctly, was equidistant to the vertices. All right? So these, all right, are equidistant to the vertices. The incenter, right, was equidistant to sides of triangle. So which represents the sides of the triangle? The streets or the cross sections or the intersections of the streets? Well, obviously it's the sides or the streets that we see right here. And so we want to focus actually on the incenter and where the incenter would be. And so since the incenter is equidistant to the sides, we want to use the incenter to find out where that lamp post actually would be. Now I'm going to kind of utilize our compass here and find out specifically where that incenter is. And so I'm going to take my compass out and I'm going to create an incenter by finding two angle bisectors. So let's go ahead and just, all we want to do, guys, to go ahead and to define this incenter, you're just going to basically find one of our points of intersection and just do our best to find out where that vertex of the triangle is in fact going to be. And I'm going to utilize the greenery on the grass just so I get a little bit better idea of where it is. And if you don't have a compass, that's okay. Just kind of follow along. I'm going to go ahead and make an arc here, and we can see that we've got an intersection on our triangle and the arc right here, and then another intersection right here. And so I'm going to bisect this angle by taking my compass, and I'm going to go ahead and I'm going to create two new arcs, all right? Two new arcs. I'm going to have an arc that goes right through here, and then I'm going to have an arc that I go on the other end, the other intersection, and I'm going to create another interior arc. And you can see where these three arcs actually come together. And what ends up happening now, guys, is that we put ourselves in a position where we can actually perfectly bisect this triangle. We can bisect this triangle. Let me put my line above. So you can see we perfectly bisected this angle here. Now I'm going to do the exact same thing on one of the other vertices. Now it doesn't really matter which one you choose, but again, you're going to kind of choose a random arbitrary arc, come on over to each of our intersections of the arc and the sides of the triangle, and we're going to create just some arcs on that interior so we can see where our points are going to intersect. And if I create that arc, I can create another angle bisector. And as you can see, we created another angle bisector by connecting this vertex and this intersection right here. But the key thing to now realize is that we now can identify where the incenter is, and the incenter is right here, all right? So the big circle that I'm making, that is that intersection, that point of concurrency. So right there is our incenter, and that would be the smartest position for that lamppost.